Generative AI Examples. We're going to look at large language models for self-tutoring, and part of this is to help you review the calculus in this course. So a large language model is a multi-scale complex model. For example, if you ask it, what is E? Well, the letter E is the fifth letter in the English alphabet. This is its reply. See, we didn't tell the large language model that the context is mathematics. Now, if we go behind the scenes of ChatGPT, this is what it looks like. This is the playground. And we can set the session's large-scale context or flavor or style. Please answer mathematically. What is E? This is a first look under the hood of ChatGPT, but I'm going to use ChatGPT itself until we need this, in part because it's not free. So please answer mathematically. What is E? And this is ChatGPT's response. It looks pretty good. It's a mashup of Wikipedia articles and other sources, but it has some ambiguity even in the first sentence. You see, E is actually called Napier's constant. Euler's number is an informal, vague reference to E. Euler's constant is a different number. It's gamma, which is about 0.577. And so mixing or mashing up the articles produce some terminology that could lead to some confusion later on. See, a careful tutor would not use constant in the same sentence as Euler's number. So E is a mathematical constant known as Napier's constant. Euler's number is a vague reference. See, teaching and tutoring requires both insight and foresight, a vision and perspective of what a student will be doing later with what they're being taught now. In fact, you may be better off just using a search engine like Google directly rather than naively relying on a large language model's mashups of the same search results you might Google. See, LLMs do not think or reason. ChatGPT does not have vision or perspective. It does not ever foresee anything, certainly not what a user is going to do with the information at a later date. It's a model that has learned the importance of scale in English language communication and how to model it. It cannot teach or tutor like a human would, but it is possible to use large language models for self-tutoring once you understand the importance of scale. For example, large language models assemble information across scales. So I'm going to show you in a large sense how large language models actually operate. Suppose we give it this passage. Walking in the woods leads to danger. Cody was walking toward a mama bear with cubs. Look out, stop, turn back, yelled a man nearby. But it was too late. The bear was now chasing Cody. Now the LLM does not read or understand as I did. It parses each word into a token. Each token is mapped to a vector in RD for a very large value of D. Each sentence is mapped to a collection of tokens, a matrix of vectors. And the large language model learns the multi-scale nature of the content itself. It identifies and associates phrases look out, stop, and turn back with each other. It does not know what danger is, but it does associate danger to those phrases and perhaps also to that phrase too late. The large language model knows that Cody is walking in the woods. So what kind of information could we trust from this large language model? Well, that a mama bear with cubs running toward something could be dangerous. That look out is a phrase that implies danger is near. But the large language model may also yield nonsensical, unsupported results. Cody is a common first name for men. Cody is also a common dog's name. But Cody with a K, that is something the large language model's never seen. Could be a misspelling or it could be just an unusual spelling of one of these names. Yet it may say that Cody is a woods, or it even might say that Cody is a danger. See, a large language model associates words and phrases across many different scales, and sometimes that's not correct. So let's look at using large language models, for example, with notebooks. A prompt is a question or statement given to a large language model to which it produces a response. A prompt has a context. The user can indicate the context within the question itself, and the response often has a format. The user can specify the format or export the result and reformat as needed. And then there are always, most often, follow-up prompts, replies to the results that the large language model returns. So here is the Anaconda distribution at the Anaconda Cloud, or you can download the Anaconda distribution and install it. Either way, you will get to the point where when you go to Jupyter Lab or the Jupyter Notebook, you'll see this screen. You'll need to confirm your age and click continue so you can use the AI assistant. It's essentially ChatGPT for Python. And now you can ask it a question. We're actually going to ask it a non-Python question. In calculus, how is e related to the function e to the x? And here's its response. But notice that it didn't really know what kind of formatting you wanted. So now we're going to have to do some work. So click and export this into the notebook. And it doesn't look quite right, but we can double click on the cell. Notice we're now using our knowledge. We get the markdown code and we realize what needs to happen is the backslash parentheses and the backslash square brackets need to be changed to dollar signs. So let's do that. We do Control F or Edit Find from the menu, and it brings this box up. We click on the little arrow and we get the replace box. And now we enter backslash square bracket in find and double dollar sign in replace. And then we click replace all. And now all the backslash square bracket open have been replaced by dollar signs. Do this again with the backslash close square bracket and the different parentheses forms with single dollar signs. And then run the cell. So you can click on the run arrow on the toolbar or you can do Shift Enter. And now you get this. Notice this is a nice response, one that you've done together with ChatGPT, this through the AI system. So when you're using large language models as assistants, for example, self-tutoring, the prompt is a question or statement given to an LLM from which it builds its response. Literally, the response is built from the prompt itself. It's a construction. And there are some initial guidelines for good prompts, not for how you talk to another person, but how you give good prompts that will give good building, good constructions from the LLM. First, describe the context, the language, the data, the library to use. Be specific within the context, no vague references. Specify what the final result should be and look like. It's okay to have a long prompt as long as the prompt satisfies these other three conditions. Specifics, smaller scales, in a context, larger scale. And then follow-up prompts often focus on a result from the initial prompt at a specific scale. For example, we in math always ask it to check its work. So with calculus as the context, define a function f of x equals exp of sine x plus cosine 2x. What is the derivative of f of x? Well, this was my prompt. It was large scale because it said calculus is the context. It had a smaller scale, specific function definition, and then across scales, I defined notation that is familiar and standard within the calculus context. And that allowed it to give me a really nice response. But don't large language models often make mistakes, have hallucinations? We've already seen ChatGPT is terrible at math. Yes, we've seen all that. So we ask it to check its work. In this case, take the antiderivative of the result. So what is the antiderivative of that derivative? And here it goes through and it does a calculation of an antiderivative. And notice that it knows what's going on. It's trying to obtain the same result. It does this correctly, and sure enough, it worked. It's surprisingly adept at direct symbolic calculation. such as for antiderivatives. In other words, if there is a very specific set of mechanical rules for doing a problem, ChatGPT tends to be pretty good at executing those. So here we find the antiderivative of cosine of square root of x. It is done using a substitution, and you have to do some algebraic manipulation within that substitution. And once you get done, you have the antiderivative. Now ask it to differentiate and make sure it's the right answer. It's more explanatory than Wolfram Alpha, which does the same thing, but without the nice conversational explanations. So large language models as assistants, self-tutoring, they're not appropriate to those with no knowledge of the subject. They can give very misleading, even incorrect, that seems to be true results. So you must know enough to construct good prompts, and you must know enough to assess the results. But it's highly appropriate for complex conversations based on multi-level specificity within a given context. So remember that a large language model is a model. It does not think. It works across scales to build its responses. So in this class, we're going to be using a large language model called Gemini Pro. Let me show you an example of basic usage, just intelligent search and exploration. Again, we have these 4 very basic guides to working with large language models. So we're going to retrieve sources from PubMed located at this URL, and it says I'm ready. That describes our context, establishes the context we want to ask questions in. What are the 5 most important articles in the past year relating COPD to inflammation other than in the lungs? And here you can see 5 articles. I'm just showing you the first and the last. You can see the full conversation at this address. But we want to have a conversation, not just a prompt. But this first question was actually just a starter question in the context. What do these articles have in common other than COPD? Well, now it does a summary. Says all of these articles talk about systemic inflation as a core mechanism. And it ends up with emphasis on high-level evidence. So they all converge on the idea that COPD is a systemic inflammatory disease with major consequences for cardiovascular and metabolic health. Are there other articles, only up to 5, on PubMed relating COPD to systemic inflammation as a core mechanism? Oh, here they are. So here's another 5 articles now specifically about the concept that it identified as being first in importance. Here's the last of the 5. Now I'm going to ask it to summarize in 2 or 3 sentences, summarize what we've learned from the search through the literature represented by this conversation. Large language models are very good at summarization. Here's what it tells us. Our search through recent literature shows a clear consensus that COPD is not merely a lung disease, blah, 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 blah. Focused on understanding diverse triggers of this inflammation. So, from the gut microbiome to the aging process itself. So, large language models can distill huge volumes of information into just a few very concise sentences, and they're very good at that. So remember, a large language model is a model that generates responses to prompts from the huge background that it learns via optimization. Remember our 4 very basic guidelines for asking prompts. So I'm going to ask about the following question. Walking in woods leads to danger. Cody was walking toward a mama bear with cubs. Look out, stop, turn back, yelled a man nearby, but it was too late. The bear was now chasing Cody. We looked at this earlier. What is the danger in this passage? Well, as we saw earlier, it says the danger is a mama bear chasing Cody because Cody walked toward the bear and her cubs. That's a very dangerous thing to do. But is Cody a danger? It says yes. because he had reckless actions. But is that a valid conclusion from our passage, that Cody was reckless? So now we're going to look at an example of calculus in Gemini Pro. You can see the full conversation at this link. So we're going to use calculus to perform an optimization. My context, I define my function, b of p equals p log p plus 1 minus p log 1 minus p, and it actually recognizes this as the binary entropy function, which is what we'll use it for in this course. What is its derivative? Well, here's its derivative. Notice that it actually used the properties of the logarithm to simplify it briefly, and it actually tells us step by step how it came up with this result. Notice that this is a combination of the product rule, the chain rule, and the sum of the derivatives is the derivative of the sum of the derivatives. So now, is that the right answer? It's a nice looking answer, but let's ask it to integrate to check its work. Excellent idea. It actually knows that we're going to be checking our work when we do math, because that is a best practice. So it integrates, then the second term, combines all that, and notice we end up with this, and we substitute that back in, and we end up with that thing. And then when we combine the two, we get the right result. Now, if you're a little concerned, and you should be, there's a minus p there. Where did that come from? Well, fortunately, when you put the two integrals back together, there's a minus p and there's a plus p, and they cancel, and we return to our original function, as it says here. Now, we know that if b of p is convex, then b of p has a global minimum. So is b of p convex? Yes, it is. Great. So it must have a global minimum. Now, here's how it actually finds the second derivative. And if you'll notice, it made some formatting errors. And we can fix those formatting errors very simply. We just need to put spaces between the dollar signs. And once we've done that, we end up with a nice result. Now, what is the argmin? Well, there has to be a global minimum, and it has to occur at an argmin, an argument of the minimum. So it sets the first derivative equal to 0, and then it solves the equation step by step. It says p equals a half is the argmin. Great. What's the actual global minimum? Well, that means what is the value of b of p at the argmin? And it tells us the answer, once again shows us how we can obtain that. And now notice, I ask it to save this conversation in Markdown for display in a Jupyter notebook. And it does so. And you can look at the notebook itself. It's on the website. So you, with large language models, can do calculus. We only explored calculus in one variable. And we'll also do linear algebra, starting in Module 3. And we'll use large language models as code assistants in Module 2, and that's actually our next video on generative AI. We'll see a great deal of calculus, especially with exponentials and logarithms in this course, but nothing you and ChatGPT or Gemini Pro can handle. Just remember the importance of scale when you're doing your prompting.